to be a part of your service already this far. It's been a blessing to be here, being reminded of God and His superior ways for us in the devotional and our need to exalt Him in our lives today because of His greatness. And so for a verse to launch off the evening now, this evening, I would like to look at Psalm 34, verse 3, where it says, "Oh, magnify the Lord with me, and let us exalt His name together." Thank you, buddy. When you get to be 36 years old, you're a little forgetful. So we are called to magnify the Lord. There's different ways we can magnify the Lord. There are some ways that we can do it through a life, a testimony. And then there's other ways that we can actually go get a mechanical device. We can get a telescope, and we can get the optics aligned just right, and we can magnify the things that God has made, and in effect, magnify Him as we interpret what those things are telling us to show His glory. So what we're intending to do this evening is to magnify the Lord through a physical sense, through the things that He's made, and therefore we could exalt His name together. So doing this, we'll be looking through a glass darkly, like we can read in 1 Corinthians. So one of the ways that we can look through a glass darkly is also looking through the glass of a telescope at these distant objects all around us. And when we do that, we see just a faint, faded, dirty, murky view of a part of God's glory. But there's a valuable lesson for us to be learned there. God has made these things in the universe around us for a purpose, and we covered a little bit of that the first evening. And His purposes are sure and true and fast, and there's a good reason for every one of them. When God sets out to do something, He always has a good reason for it. And when He made the universe around us, He made it in such a way that it speaks of Himself. And like you heard the very first evening when Tom got up here, it's basically impossible to be an atheist out here in this part of the country when you look around and see all that God has made. Well, God has placed such a powerful message in the heavens around us and the earth around us too, that the things that He's made in themselves are enough to hold us accountable before Him. Romans chapter 1, verse 20 makes this clear, where it says, "For the invisible things of Him from the creation of the world are clearly seen, being understood by the things that are made, even His eternal power and Godhead, so that they are without excuse." So the scripture there tells us that just simply looking at the things that God has made, even if we're not exposed to this, the Word of God, we are held accountable before Him because of the nature of the powerful message coming from all around us. So if this message is that important, then I think it can do us good to spend a weekend looking at it, at least one weekend. And of course, we don't want to do it at the expense of the greater revelation that God has for us in the book of His Word, but there's also the book of His world, the book of nature that we can learn from. And it's interesting how that God has made the universe in such a way that the book of nature illustrates the book of His written word in so many ways. And I think that's one reason why Jesus drew from examples in nature so often, because those are illustrations for the truths that He was teaching. So what we want to do this evening is look through a glass, look through a telescope, and see what the universe around us looks like. And we'll be looking primarily through optics that are available to most of us. If you choose to buy a telescope, most of these pictures that I'll be showing this evening were taken through a telescope tube, an optical tube assembly that costs either $500 or $600. But of course, there was a mount that added to the cost and the camera and those sorts of things. But these things are extremely accessible to us, is the point. And we want to see how they declare God's glory. So again, if you weren't here earlier, and you want to kind of know what you're looking at, when you see the R logo at the bottom right corner of the screen, then you know that you're looking at a real picture. This, of course, is a composite of 6 different pictures put together into one. So it's not an actual view that you get of a specific region in space, but this picture is made up of real objects, real pictures, declaring God's glory. I want to start off with some questions that God was asking Job. And this was when Job was having his trial. He was having a hard time, a difficult time. Then the Lord answered Job out of the whirlwind and said, "Where wast thou when I laid the foundations of the earth? Declare if thou hast understanding. Who laid the measures thereof, if thou knowest?" So God was asking Job, what are the foundational aspects of this universe, and how did God put together probably the laws of physics and all those things? If you can understand those things, tell me. And then God went on and asked Job lots of other questions. He asked him a total of 64 questions. And he talked about all kinds of things that he was doing in his universe. And we want to look at just a couple of those questions this evening. But in effect, God basically gave Job a creation presentation that day. And we want to see what some of those things are that God talked to Job about. And we can see kind of some of those things that God wanted to show Job when Job was sick and he had a terrible time. He was laying there in sackcloth and ashes, and his friends came and they were mocking him. And his wife, the one source of strength that he should have still had, she even turned against him by turning him against God, attempting to turn him against God. So let's move on here. One of the questions that God asked Job was, "Canst thou bind the sweet influences of Pleiades?" When we look at Pleiades today, we can see a star cluster. They're also nicknamed the Seven Sisters. The Bible calls them the seven stars as well as Pleiades. And what you see in the background here is an actual photograph of that cluster of stars. So through a telescope, you can see there's lots more than seven stars. There's over 100 stars here, and there's lots of background nebulosity there as well. Lots of cosmic dust spread through the stars, and it's just a picture of beauty. So this is the first one of a lot of pictures that I'll be showing, and this was taken with a 10-inch telescope, so that means the tube is 10 inches around. It's about 3 feet long. It's a reflecting telescope, and this is what we can see through a view like that. Now, I'll be quick to say that you can't expect to get the same view if you look through the eyepiece. A camera has the benefit of leaving the shutter open for minutes and even hours, and sometimes multiple nights, to get a brighter image and a more colorful image than what you would see through the eyepiece. But we can see there's definitely sweet influences here, lots of beauty. And God was asking Job, "Can you bind this cluster?" We, of course, couldn't do anything like that. Job couldn't do that. But in effect, God has done this. It turns out that today, astronomers tell us that this is what's called an open cluster. So it's somewhat loosely, gravitationally bound together. That means the stars are actually bound together, and they're moving through our galaxy at a high rate of speed, and the stars are all flying together like multiple suns on a journey, and they're being bound together by the one that created them. Can God do that? Well, obviously, he has. Can we do that? Not even close. And so as God asked Job question after question, it was the same story all over again. God could do it, and Job couldn't. So the message that he wants us to get, one of the messages, is that we are not sufficient of ourselves to handle the things that he brings us through in life. But we need his help, and we need his strength to be able to walk the pathway that he's laid out for us. The second part of this same verse, he asks him, "Can you loose the bands of Orion?" And most of us probably know kind of what the constellation Orion looks like. In fact, you probably recognize it on the screen up here right now. So this is the constellation Orion. Here are the two bright stars of his shoulders. And over here, let's see if we can get this pulled up. There we go. The three bright stars of his belt. This is the lower part of his body. And the upper part, here's his head back here behind the scripture verse. And then we have the sword of Orion hanging right here. But our attention right now is on the belt, these three belt stars here. God is asking Job, "Can you loose the bands of Orion?" And in effect, that's exactly what God is doing. Those three stars are slowly moving apart from each other. And so in effect, God is loosening the bands of Orion. And that's something he can do, but we can't do. If we look at it through a telescope and long exposure photography, we can see again that there's lots of other stars there, lots of additional nebulosity that we can see there. And so I'll just pull up this view of it here. And there's definitely more to see through long exposure photography. Amos 5:8 takes these things that God has made, the 7 stars and Orion, and causes us to turn our attention toward the maker of those things. So that's one of the reasons they were created, so that they can be a reflection of their creator. Seek him that maketh the 7 stars and Orion, and turneth the shadow of death into the morning, and maketh the day dark and dark with night, that calleth for the waters of the sea and poureth them out upon the face of the earth. The Lord is his name. So he's the one that's in control of all these processes, these things that are happening, and we are to seek him. The Lord is his name. Next, we'll take a look at images from deep space like galaxies. Those are the first ones we'll look at. And the Lord has garnished the heavens with his spirit. Job 26:13 tells us this. This is another one of the things that God revealed to Job. So here we have the Andromeda Galaxy. We talked about this earlier this weekend. And this one here is big enough in our telescope, in my telescope, that it actually expands beyond the field of view. And so I have to crop part of it out just to get a picture of it. The rest of the galaxies that we'll look at are all smaller than the field of view. And so we'll move on to a few others. This one here is actually a cluster of galaxies. It's called the Coma Cluster. And all of these smudges of light that you see here are actual galaxies. And all of them have millions and billions of stars in them. And I've just zoomed in. I have a call out there of the region that you see here. So there are lots of galaxies in this image. Some of these are stars. Whenever you see diffraction spikes like that, then you know that the light was coming from a point source. And so those are stars. The diffraction spikes come from the spider vane that's holding the secondary mirror in place on the telescope. So there's a support there that looks just like the diffraction spikes there. And so that only shows up when you have a pinpoint source of light, for example, when it comes from a single star. Here's another group of galaxies. They're a part of Markarian's chain. These are elliptical galaxies. They're kind of like formless globs of stars. And then we've got other stars or galaxies like this that are irregular galaxies. We have some spiral galaxies in here. There's another spiral galaxy. Here's another one. Those have structures. They're usually flat, like a disc, and they have spiral arms, like this one here. And this group of galaxies is called the Leo triplet. So it's in the constellation Leo, and we can see that within about a little less than a 1 degree field of view. They're fairly close together, 3 large galaxies close together. Similar to what we see here, an elliptical galaxy right here, a spiral galaxy there, and an edge-on galaxy right here. This galaxy would look like this one if it was tilted more face-on toward us. Here's another irregular galaxy and another group of 3 galaxies. These are all almost edge-on toward us. And then we have others here. There's quite a variety of galaxies all through the universe. And I've just taken pictures of a number of these, and you can see some of this variety. Here's the Horseshoe Galaxy, and a few others. Some of these I'll point out the names, some I won't, and some I don't know the names. Here's the Needle Galaxy, and this is M81 over here, and I think this is M106. A lot of these are spiral galaxies, and as you can see, there's lots of interesting shapes and sizes. This is the Deer group of galaxies here, and then down here is a group of galaxies called Stephan's quintuplet. So there's 5 galaxies that are actually interacting together in that area. And you've probably heard, well, of course, if you've been here this weekend, you've heard of the James Webb Telescope just a little, but it's been all over the news recently because they have this new big telescope out there that's looking at galaxies with an unprecedented resolution. So one of the first targets that they imaged with that telescope was Stephan's quintuplet right here. So I don't have, what we have here is just a zoomed out view of the whole field that was taken with my 10-inch telescope. But with the James Webb telescope, we can see what it looks like in much greater detail. So I'll actually put that up on the screen here, and you'll be able to see it. There it is, the Stephens quintuplet galaxy group through the Webb Space Telescope. And so you can see lots of extra detail here, and we can see processes going on. One thing that you notice is that these galaxies almost look somewhat, almost like a see-through quality with these pictures with the James Webb telescope. And one reason for that is because this telescope is looking at infrared wavelengths. Infrared radiation can pass through dust much easier, so you don't see the dust lanes in the galaxies blocking out the background stars as much as you would with an optical telescope. So that's the reason why it has this more of a clarity and an ephemeral glow there. So that's the reason for that. Now here's another group of, or a group of photos that I've put together of more galaxies. This is the Sombrero Galaxy. It has a dark disk of dust encircling around the perimeter of it. This is the Sunflower Galaxy. Here's the Black Eye Galaxy, the Whale Galaxy, and just quite a few other galaxies here. Lots of interesting shapes and sizes. And this is a pair of galaxies here called M81 and M82. The Bode's Galaxy right here is the actual nickname for it. And unfortunately, this one is the Cigar Galaxy. But of course, it's not a cigar, something much better than that. This here shows the two galaxies, and then in the background, you see lots of dust there. So that's an intergalactic flux nebula. And this dust kind of permeates the galaxy. In order to be able to pick up on the dust of this, in the background dust on this image, I had to have an exposure time that I think was approaching 10 hours. It was probably at least between 5 and 10 hours. I was allowing photons to trickle in on the camera sensor for that amount of time, and so I was able to pick up on that background dust that permeates through our galaxy, especially in the region close to the North Star, and that's where these galaxies are, up in that northern region. So moving on, we'll see others, and these now I'm switching to the Hubble Space Telescope. This galaxy was imaged by the Hubble telescope, which is out in space. It's orbiting around the Earth, and it's a barred spiral galaxy. That means it has a central bar. This bar of stars, they move together, and then the spiral arms extend out from that central bar. Then we have a pair of galaxies here that have actually passed through each other, and they're nicknamed the Mice. And these two galaxies are superimposed in front of a background of lots of other galaxies. And here's another one called the Tadpole Galaxy. It had an encounter with another galaxy down here and has strewn stars across the field of view here. When we think of galaxies merging or passing through each other, we tend to think that there must be lots of cataclysmic collisions in the galaxies when this happens. But since there's so much empty space in these galaxies, the star collisions really just practically don't happen. As far as we know, they're basically free of collisions. Now, it might happen some, but it's very seldom. If you remember, there was an analogy that we had last evening about our galaxy and the amount of empty space within our own Milky Way, and that was that if we would have the Earth and the Sun in this auditorium 50 feet apart from each other, the nearest star to the Sun would be 2,000 miles away from us. And we're in a highly densely populated part of the universe, and the stars are still that far apart. So it shows how there's so much empty space, so these galaxies can pass right through each other, and the stars mostly will not collide. But there is a gravitational effect that it has, and it spreads stars around, it rearranges them. This one here is M51, and a lot of these galaxies have an M in front of a number, and the reason for that is because that's short for Messier 51 in this case. And that's because Charles Messier was a comet hunter, and he would look out and try to find comets at night, and he kept running across these fuzzy patches of light that looked kind of like comets, and so he started writing them down in his books so that he wrote down the position so that whenever he would come to a fuzzy patch of light, he could check his logbook and see if that was something he had seen before, and that way he would know it's not a comet, and he would keep looking. So there are, I think, about 109 Messier objects, and those are some of the brightest deep sky objects to see, nice objects to see in a telescope. So this is M51, and its nickname is the Whirlpool Galaxy. And it's a really special galaxy because it is in our local group. It's fairly close to us, and it's one of the few spiral galaxies that's close to us, and it's also face on toward us where we can see it in all of its glory, the spiral arms channeling our attention inward. There's lots of colorful regions there. And the Hubble Space Telescope took a picture of this galaxy, so we'll zoom in on it and take a look at it here. You can see lots of red nebulosity scattered through the spiral arms. Those are hydrogen clouds within the spiral arms. And astronomers wanted to see what the center of this galaxy looked like. So here's a close-up view of the center of the galaxy. But of course, they wanted to see what the very core of this galaxy looked like. So they took a close-up image of the center that you see here in this beautiful galaxy that God placed only about 30 million light years away from us in our local group. And what do you see but the appearance of a cross as viewed from the bottom of a hillside? Now, I don't want to over-sensationalize this, but I do recognize that God made this galaxy look just like it is right here in the center. And it looks like this from night to night, from year to year. And God usually does everything for a purpose. And so maybe there's a chance that God is wanting to give us another reminder of Him and the way that He's made for us to be saved. When so many of unbelieving mankind today have looked all across the earth and they've seen all the testimonies of God and His creation here on the earth. They've been exposed to His Word, but they've rejected that. And instead they're looking millions of light years out into space to try to discover the reasons for our existence and how we got here and why we're here and all those things and the meaning for life. And once again, God is faithful to give them another reminder of what He has done for us to save us from our sins and to bridge the gap between us and Him. Here's another picture where the credit goes to NASA, a spiral galaxy, very interesting galaxy with spiral arms that extend far out from the core. And here is another picture of the Sombrero Galaxy that I showed you earlier. But again, this was taken by the Hubble Space Telescope, so much sharper image and larger image. Psalm 102:25 reminds us that the heavens are the work of thy hands. So all the glory goes to God for what He's done. There's lots of beauty there. This pair of galaxies is nicknamed the Rose. And this was taken in celebration of the Hubble Space Telescope's 21st anniversary. They took this image of this photogenic pair of galaxies. Now what we have here is another view from the James Webb Space Telescope. These pictures that I've been showing were just released just a couple weeks ago. And what you see here is a massive cluster of galaxies. And it's also called a lensing cluster. And the reason for that is that there are galaxies out here that look like elongated strings. And I'll just zoom in on that and you can see it better. So what we have here are galaxies that have been distorted and taken out of their actual location and superimposed on the edges of this image. So these big galaxies that you see through here, like this one and this one, some of these here in the center of the image, there are so many stars there that it's actually almost like putting a dent in space. And so space, the fabric of space itself, we call that space-time, is being curved inward toward those galaxies. It's kind of like if you take a trampoline and you set a ball on the trampoline, a heavy bowling ball, it would bend the net downward or the trampoline surface downward. And then if you would take a tennis ball and throw it past that bowling ball, it would actually curve around that dip in the trampoline. It would curve around that bowling ball. So what's happening here is these galaxies out here that look like strings are actually in the background in the center of the image. But as their light comes past this massive cluster of galaxies that's in the foreground here, it goes past that bending of space-time and the light gets bent back inward and it converges. The light rays converge in our telescopes here on the earth. So what's happening here again is that these galaxies are actually close to the center of the image, but the light that they sent out was on a direction to go past us, out either side of us, but en route to us, the light was curved inward toward us. And so when that happened, it distorted the view of the galaxies and put them out to the side here. So you see quite a few distorted galaxies here. There's one, over here's one, here's one, here's one, there's one, there's one, there's one over there, and then quite a few in this area right here. So these are this is a picture of how space-time can be distorted. And when space-time is distorted, not only does it affect light rays and the path they take, but it also affects the curvature of space, and so gravity is changed right there. And since space and time are woven together, it also affects the flow rate of time. And we might look at that later on. For over 100 years, astronomers have tried to catalog all these galaxies they were finding, and at the end of the 19th century, nearly 10,000 galaxies were counted. And as telescope sizes grew, there was an estimation of 100,000 galaxies. They were trying to record them, put them in the books, give them names. And so they kept going, and they kept finding bigger and bigger, or more and more galaxies with their bigger and bigger telescopes. Still ignorant of the utter impossibility of the task, astronomers in the 1950s to 1980s used powerful telescopes with special cameras attached to aid in the search, and powerful computers with shape recognition software had to be used to count the legions of galaxies on the images. Tens of millions of galaxies were counted before the project was abandoned, and since then, no further attempts have been made to count all the galaxies because it just can't be done. There's too many of them. Even with the help of supercomputers and powerful telescopes, we can't count all the galaxies. Now, they're still cataloging galaxies, but the ability for us to detect galaxies has grown exponentially faster than our ability to record them. So it's kind of like a hopeless task right now as we try to keep up with the amount of galaxies that are being discovered. So there are archives online where you can go on and see lots of images that have been flooding back from the Hubble Space Telescope, for example. And those images, they are downloaded from the telescope and they're put onto these archives, and then they're there for astronomers if they ever want to reference them in the future. So you can go on there and you can pull up some of these images and you can look at these faint galaxies way out across the universe, and you may actually be the very first human that ever laid eyes on that galaxy. And so that galaxy has been there filled with millions and billions of stars for all these years, and it's there for a purpose. God made it for a reason, and now you're just now seeing it. And God made these things for His glory and for His pleasure. And like I mentioned earlier, what He takes pleasure in, He wants us to take pleasure in as well. So if we see those things that He's made and we compliment Him for doing it, in other words, we praise Him for it, then part of the reason for their creation is being fulfilled at that time because He is receiving glory and honor from what He has made, which is, incidentally, the reason that He made them. Lift up your eyes on high and behold who hath created these things, that bringeth out their host by number. He calleth them all by names, by the greatness of His might. We can't count the number of galaxies, let alone the stars within the galaxies. But the Bible says that not only does He know the number of all the stars, but He also calls them by name. What does that mean? I don't really know, but it's mind-boggling to think that the Creator must have a name for each one of these stars. And so this little blue star that you probably didn't even notice before I pointed it out to you is special to God, and He created it, and then He gave it a name, and He calls it by name. If He wants it to produce a planetary nebula, He can give it the command and it throws off this beautiful halo of gas and dust around it. If He wants it to cause a supernova explosion, He can do it, or give it the command and it causes these celestial fireworks. And maybe He wants it to appear in our night sky, and so He can make it go through a process like the star that caused the Crab Nebula that we'll look at later on this evening. That was all of a sudden, it was a new star in the sky. The Chinese called it a guest star. It was so bright you could see it during the daytime. So God does these kinds of things with the stars. And if He has this many stars to keep track of, then does He have enough time for me and for you? Well, God is outside of time, of course. But sometimes when we think of for ourselves, we have limited resources, limited time, limited faculties up here, we're limited in so many ways. But God is looking after all these things. Well, there's at least 3 reasons why God would care more for us than all the stars that are out there. One is that God created us in his image. So in effect, when he looks down and sees us, he sees a mirror image of himself. And wherever he sees himself, he sees value, obviously. And so for that reason, God cares for us. And secondly, we're the only part of his creation that he has literally invested his life in. And if we have an investment, we have a keen interest in that to make sure that that investment can flourish and increase. And so in the same way as God has given his life through the life of his son for us, he wants us to be his investment, to be able to flourish. And he wants to pour his grace out on us so that we can do the work of his kingdom and bring glory to his name. And he wants us to be able to be obedient and victorious in our Christian lives. And then thirdly, we're the only part of his creation that he has given us the ability to consciously praise him and speak to him and have a communication with him. And it's not just a one-way communication, but it's a reciprocal communication. We speak to him and he speaks back to us. And we can praise him not just autonomously like the stars and the sunsets and the birds and the trees, but we do it from a true heart, and therefore it's a sacrifice of praise. And so it's much more valuable in God's sight because of that. It's not just a robotic or autonomous praise like the rest of creation. Jeremiah 32:17 says, Ah, Lord God, behold, thou hast made the heaven and the earth by thy great power and stretched out arm, and there is nothing too hard for thee. So if God can make these enormous galaxies, then he can take care of every one of our problems without a problem. And I like the way that, I think it was Ralph Waldo Emerson put it. I saw this quote on a wall on one of my trips. We stayed in a guest house or one of our host house. They had a bedroom for us. And on the wall, I saw this quote, all I have seen teaches me to trust my Creator for all I have not seen. And like in the devotions this evening, there are things that God shows us and gives us the faith to move on through the things that feel like we may have a blind spot. Places and times where we can't fully understand, but we can look at those things that he has brought us through in the past, and we can look at the testimony of the lives of others, and it gives us courage to move on. And when we see God's greatness and glory and might displayed across the universe, then that gives us the confidence that he is an all-sufficient God, and he is also a God of providence. He will provide. Now we'll take a look at reflection and emission nebulae, and this is what really gets me excited. When I go out there to my telescope, or if I'm in the house or wherever I am controlling the telescopes, I can move that telescope to somewhere in the sky and open the shutter, and usually just to explore around, I just open it for a matter of a few seconds or a couple of minutes, and who knows what it's going to look like when that picture comes back. And it might be this beautiful cloud of colorful gas out there that's actually light years in diameter. And so that's what we have here. This is the Lagoon Nebula. So we're stepping back to the 10-inch telescope again. And this is a gigantic cloud of hydrogen gas, primarily hydrogen, close to the line of sight of the center of our galaxy. And there's lots of dark clusters of opaque dust that's rising up here in front of the background gas as well. And so it adds kind of some character and texture to the nebula there. So that, again, is called the Lagoon Nebula, and it is an emission nebula. So that means that, let me back up to it, that means that starlight is shining onto this gas, and the ultraviolet light from the stars is exciting the hydrogen gases, causing them to glow through a process called ionization, and that makes so they release photons, and the photons are what land in our eyes and make us realize that there is a gas cloud out there. And it's just amazing how God has created our sight as well. If you go outside at night and you look up in the stars, you might not see very many stars right away because our eyes take a few minutes to dark adapt. In fact, it takes about 20 minutes and maybe even a little longer to completely darken that. So remember that when you go outside on a good dark night. But when these photons strike our eyes, we are not actually looking out there at those objects, or our vision isn't reaching out there. All that we're seeing is little particles of light. Well, they're not particles, but they're packets of energy that have struck the retina on the back of our eye. And then that's converted into an electrical signal, so it's kind of like a tiny shock that goes through the optic nerve and to our brain. And what our brain receives is a series of tiny little electrical impulses, tiny little shocks. And so it interprets those shocks and helps us to understand what we're seeing. So in effect, there are these packets of energy that cross the universe and land into our eyes, and then we see that image in our eyes after the brain converts it to what we actually see. So it's all in a process that is complex, but yet glorifies God. Now you notice color, there's lots of color in that nebula, but if you come to our observatory there in Montezuma, and we welcome you to do that. Now, of course, we're on the other side of the country, but if you're ever in that area, you're welcome to stop in. You have an open invitation, and the cards that we have on the table have our address, so feel free to stop in, and we will treat you to a view of some of these things. But you won't see the color in the Lagoon Nebula if we look at it through the telescope. Unless you have really sensitive eyes, you probably won't see much color at all in these nebulae, and there's a couple of reasons for that. I'll cover it here with this illustration with the Orion constellation here and some of the gas in this constellation. So here's the shape of Orion. You can see the club he's holding over his head here. Then there's also a bow that he's holding out here. These are the three bright stars of his belt, and these are the three stars of the sword that's hanging from his belt. The central star is not actually a star. It's a cluster of stars and a complex of gases and some dust. So I'm going to zoom in on that. We'll pull it up here, and you can see what it looks like through a small telescope, through maybe let's see, this is probably about a 4 to 6 inch telescope. That's about the view that it would give you here. And you can see it's just a kind of like a monochrome grayscale view of some wispy gases. But if we could take a telescope or get a much bigger telescope, then we could have a bigger light funnel and we'd see lots more structure and maybe even more hints of color. But if we take a camera and put it on the telescope, then we can actually open the shutter and let the light accumulate for a while, and so we see more color. What's going on here is that we don't have enough light coming into our eyes to actually activate the cones in our eyes. The cones are what detect color. So it's the same thing that happens when we go out at night and we look around on the horizon. We might see a tree and a truck and a barn, and we can see the shape of them, but we can't see what color it is. We can't see the color until the sun rises and adds a lot more light to the situation. It's then that we can see that the truck is blue and the barn is red and the tree is green. So what we can do here is add more light by letting it accumulate on a sensor. And so what I'll do is I'll simulate a 10-second exposure here. So we'll start the exposure now, and you can see by the dial as the exposure progresses. And as we're increasing the amount of time here, we can see more structure being displayed. We can see the color really popping out. Now we're left with an actual image of the Orion Nebula through a camera, a regular color camera sensor. And the sensor that I use on my camera is one that's found in quite a few DSLR cameras. And so these are the actual colors that are in that area. And there's lots of areas of dust that have been carved out here by the stellar winds. And there are lots of colors here. It's just amazing to see this masterpiece of God's creation. It's one of the brightest nebulae in the night sky. So this color is there, but it's not very obvious to us with the limitation of our eyes. Now, just above the Orion Nebula, you can see the Running Man Nebula, and this bright area down here is actually a part of the Orion Nebula. So just above it, there's the Running Man Nebula. It's called that because of this shape that you see here. Here's the head, here are the legs, there are the outstretched arms, and that's the reason for the nickname that it's got. This is real close to the constellation Orion, And it's called the Seagull Nebula. And a lot of it is cropped out of this picture, so you can't see all of it there. But there's others. This one has lots of hydrogen gas. The red gas is typically hydrogen gas. And this is a part of the Orion Nebula too. So when you look at the Orion Nebula, when you look at the constellation of Orion and you look at those 3 belt stars, you're actually looking right through this complex of gas and dust. And so you're looking right through this cloud here, but it's not very obvious because it's not very bright. But through a camera, you can see what's actually there. This is called the Horsehead Nebula, and this is one of the stars of the belt of Orion. And then down here's the Flame Nebula. Here's a region of gas and dust, a reflection nebula down there. So moving on, we can see other beautiful masterpieces of God's creation. And this one here, right here, is just a close-up of the horsehead shape there in the Horsehead Nebula. Close-up view of that. This is M78. This is also in the constellation Orion. Orion is full of deep sky treasures like this. Lots of cosmic dust surrounding that area and colorful gases mixed in with it. The universe has been nicknamed as being has been called God's art gallery. So it's a way that God can exercise his creativity and demonstrate his appreciation for beauty and variety. As you see here, this is 2 clouds of dust and gas that are nicknamed the Spider and the Fly. And then we'll look at the next one here. This is a region of the dusty region in the galaxy. And the name of this is NGC 1333. It doesn't really have a nickname, but it's got a new general catalog number of, I think, 1333. And then here's another region, dusty region close to the center of our galaxy in that direction, according to our line of sight. And you can see stars shining on the dust around there, and it reflects the blue light from the stars, and then some of the yellow light as well down in the lower corner. And close to that same region, there's the Trifid Nebula, and that's what you see here. Blue gas superimposed there next to the magenta, pinkish, reddish colored gases. And then this, what you see here, is also close to the constellation Orion. This is part of the Rosette Nebula, and you can see what these dark areas of dust, cosmic dust rising up in front of the background glowing gas. Those are called Bach globules. And there's a few stars mixed through there as well. And then we have the Omega Nebula, also called the Swan Nebula. Without a telescope, the main thing that stands out is this shape right here and this curved shape right there. So it kind of looks like a swan floating on water through a telescope. This here is the Eagle Nebula. So it's an amazing reminder of what God has created, and I will take another look at that later on. But what we have here is part of the Angel Nebula. It's wispy gas and dust spreading through this area of space with, again, cosmic dust stretching through the image right there as well. Then moving on, we'll see what we have next. This is in our Milky Way. If you look up into that Milky Band of stars, you can see this Crescent Nebula here. And this is in the constellation Cygnus the Swan. And it's just another interesting cloud of gases there. This is the Elephant's Trunk Nebula. So you can see it looks kind of like an elephant trunk there. Lots of hydrogen gas around that area. And this one here is the Iris Nebula. There's a bright star here, and it's lighting up the dust around it. So the dust around here, even though it's bright blue, it's actually the same type of dust that you see out here. But this star is so bright that it's actually shining on the dust and lighting it up with its own bluish light. And the next one here is the Pelican Nebula. And that's real close to the North American Nebula, which we'll look at next. And this is just a small part of the North American Nebula. The whole nebula looks like the continent of North America, with Florida coming down here and the East Coast there, then Mexico down here, come on up to California, and then where you are up here. But I just have the Mexico region on this image. So it was too big for me to take a picture of the whole thing. And then there are bubbles out in space. This is called the Bubble Nebula. A star created this bubble by an eruption of stellar material out of it. This is called the Cocoon Nebula. And then this here is a star in the constellation, Cassiopeia, and it also has a mountain of dust extending up toward the star, so it's an interesting view there as well. This is the Lobster Claw Nebula. There's lots of different shapes and sizes of these, lots of different colors. This is the Tulip Nebula. And the next one is another region in Cygnus the Swan. It's just a vast complex of hydrogen gas that extends far beyond this image. And the blue area right there in the center of it was a reflection nebula. So the starlight was shining on that dust, the dust and gas in that area, and reflecting its own blue starlight off of it. And so these pictures here now are just big clouds of hydrogen gas. This is called the Sol Nebula. I actually had to take 3 pictures, put them all side by side to get that entire nebula in. This is NGC 7822, and these are all declaring God's glory. This one here is a part of a supernova remnant. And what happened was there was a star way down here below the field of view that exploded, and it sent these tendrils of gas expanding out through space. And so we got just a part of it there in the frame. And this is another supernova remnant. So there was a star that exploded here. It's not related to that star. That's just a bright star in the foreground. But this star here produced what they call the Jellyfish Nebula. This is the main part of the jellyfish, and its tentacles are hanging down, or actually hanging up in this image. So that's another view of a supernova remnant. By his Spirit he hath garnished the heavens, Job 26:13 tells us. And so that happens here in all of these images. This image, or this nebula, is called the Pac-Man Nebula, and this is Melotte 15. It's a part of the Heart Nebula. And these 3 pictures are also supernova remnants. They all come from the same exploding star. This is the Western Veil Nebula, the Eastern Veil Nebula, and the Pickering's Triangle. And then there's a few other things here like the Rosette Nebula, the California Nebula, the Fishhead Nebula, and the Flaming Star Nebula here. And then over here is the Monkey Head Nebula, and Thor's Helmet, the Cave Nebula, and another region of hydrogen gas there. And just a few others that we can see here. Now these, what you're looking at, are planetary nebulae. They don't have anything to do with planets, but in a small telescope they look similar to planets. So they've been nicknamed planetary nebulae, but they're caused by stars that puff off shells of gas. It doesn't disrupt the star to where the star takes on a different nature after the explosion necessarily, but it's enough of an eruption that it produces things like this: the Owl Nebula and the Headphones Nebula, the Robin Egg Nebula, the Diamond Ring Nebula, and the Dumbbell Nebula. And then there's the Helix Nebula. We looked at this one earlier. This is a view through the 10-inch telescope. And then we have the Hubble Space Telescope images. This is a part of the Lagoon Nebula, and this is part of the Cone Nebula. And this here is the Eagle Nebula. Now, in order for us to get a context of how big these things are, I want to zoom in on the central area of this gas cloud right here. And you can see 3 pillars right there in that yellow rectangle. We'll zoom in on it, and you can see what's been nicknamed the pillars of creation. And these pillars are huge, if that word fits. This pillar here on the left is about 4 light years from the top to the bottom. And if we were to put the Earth on this image, we couldn't see it. It'd be too small. And of course, we could fill the sun with 1 million Earths, but even if we put a circle on here the size of the sun, it would still be invisible. So the next step up is we could take the entire solar system, which is so big that if we were to fly across it at the speed of a jet, which is about 600 miles per hour, it would take us about 20 lifetimes of flying day and night from the time we're born to the time we die. But a disk that size on this image would still be less than the size of 1 pixel on the image, so it wouldn't be properly resolved yet. So what I'll do is I'll take our solar system and put it on here times 40 in size. So it'll be a yellow circle at the end of the white arrow, and there you see it right there. That's our solar system times 40, and it's completely dwarfed by this 1 pillar on the left side there. Now this pillar is a false color view, but I wanted to get a full color, an actual color picture of it with my telescope, so I did that here. And with the way I processed it, I used a computer to remove the stars, so it kind of helps us to focus on the actual nebulosity itself. And you can see some of the more true natural beauty here with the actual colors that are in this nebula. So it's just an amazing part of God's creation, one of my favorite locales in our galaxy, the pillars of creation. Now back to the image that we looked at earlier. This is a false color image. A lot of the images that come from to us in astronomy come from telescopes that have monochrome cameras. So all the pictures are taken in black and white, but astronomers go and they add specific colors to certain wavelengths of light. And so they add color to the image after the image comes back. And this has scientific usefulness, because then at a glance they can see what type of elements there are in different regions of the nebula. All right, so back here again, we can see the pillar on the left that's 4 light years long. It's completely dwarfed by the entire Eagle Nebula. And these are the claws of the eagle. This is the head of the eagle here, the outstretched wing out here, the tail there, and another wing out here. Over here is another pillar that's 9.5 light years long. So it's about twice the length of the other pillar that we looked at. And this picture has a slightly different coloration. And so this pillar here is extremely long. If the Earth were here, the nearest star would be about halfway up this pillar. So this thing extends out beyond the region of the nearest stars to us, if the Earth were right here at the base of it. Up there at the top, you can see a concave shape that's pushed out of it. And this is just kind of a reminder of how stars sculpt these nebulae. So there's a star just outside the field of view here that's giving off lots of radiation, and it's eroding out the top of that pillar. So these nebulae, they actually change over time. And these stellar winds are sculpting and changing and blowing out this gas and dust, and it's causing it to change over time. The gas is billowing around at thousands of miles per hour, but since the entire complex is so big, it's actually not noticeable from night to night with our telescopes. But if we take pictures from year to year, then we can see some of that change happening over time. This here is part of the Carina Nebula, and it's about 10 times bigger than the Eagle Nebula that we just looked at. So these clouds are enormous, and we can see specific parts of it here. There's a pillar in this nebula that I'll flip upright, and you can see how it has fingers of dust extending out from it. We can zoom in on it again, and there's dust and gas here. And in the tips of the fingers, there are actually stars nestled in here that are giving out jets of energy, and they're causing shock waves in space as they plow into the region of space around them. So there's 2 jets here, 2 jets there, and shock waves that are caused by those jets. And so here's just another picture of a supernova remnant, and this is part of the Heart Nebula. And this one, okay, now we'll move into planetary nebulae that were taken by the Hubble Space Telescope. The images were taken by Hubble. This is the Retina Nebula, and the next one is the Helix Nebula, taken by the Hubble Space Telescope. And since we have better resolution here, we can zoom in on this one, and we can see how the thicker clumps of dust, denser clumps, are being left behind as the looser gas is being pushed away. And then over here is the Cat's Eye Nebula. You can see some intricate design and concentric shapes in these patterns. This is a nebula that's actually an eye looking right back at us as we look out at it. And it's a reminder that the eyes of the Lord run to and fro throughout the whole earth, and he sees everything that happens here. He sees every need that we have. That's the context that this verse was written in. And he also sees everything that happens, and we're held accountable before this Creator God. So here's the Eskimo Nebula, and we have another one called the Ring Nebula. We can get a close-up view of this. This is a really good object to look at through a small telescope as well. It looks like a smoke ring in space. And then this one is the 8-burst nebula. And it looks almost like a gem or a ruby like we have here on the Earth. But when they used the James Webb Space Telescope to kind of see through it, then they got a different view. So this is one of the targets that the James Webb took in its first imaging run. And so I will change this to the James Webb view, and there you see it. So now we can see more of that structure within the nebula itself. So this is James Webb Telescope, and this is Hubble. Back to the Webb Telescope again, and back to Hubble. So you can see how that there's detail that's showing up that we wouldn't have seen otherwise. And that's because the Webb is looking at different wavelengths of light. So our eyes are tuned into only a very small segment of the electromagnetic spectrum. But we have telescopes looking at lots of other parts of the spectrum and getting different information and seeing different things. Now this is the Butterfly Nebula, and this is a diagram of the different types of stars. So we're finished looking at pictures of gas and dust and nebulae, things like that. But what I want to do now is transition into looking at some of the objects in the universe that are unusual. So the Bible tells us that there are different types of stars. And we can see that in this chart here. 1 Corinthians 15:41 says, there is one glory of the sun, and another glory of the moon, and another glory of the stars. For one star differeth from another star in glory. So there are lots of different types of stars, and we can see those different types in this Hertzsprung-Russell diagram. These are the main sequence stars, and the sun is right here, a yellowish white star, and it's in this highly crowded region in this very highly populated group. Then we have white dwarfs down here. We have giants up here and supergiants here. Now these things are categorized in a way that as you go farther to the right, the stars are cooler, and as you go farther to the left, the stars are hotter. So you can do signs from your own backyard. At first glance, it looks like the stars are all white. But if you look closely, you can see that there is a color in the stars. The blue stars are about 10 times hotter than the red stars. The farther we go up this scale, the brighter they are, and the farther we go this direction, the bigger they are. So you can see some of those relationships and how they correlate with each other. So here is a cluster of stars. You can see here fairly clearly that some of these are yellow, some are white, and some are blue. This is M13, and it's about what you would see through a 16-inch telescope. And it might not be quite as bright as this unless you have a good, dark, clear night. And then this is another picture of it, or actually this is a different one. This is the Omega Centauri cluster, the biggest cluster in our galaxy. These are globular clusters that orbit around the center of our Milky Way, so they actually come up out of the plane of the galaxy and orbit around the center of it. There's estimated to be about 10 million stars in this one cluster. Next, we'll look at extreme objects in space, and this right here is a supernova remnant, but it's a more recent one, and it was recorded by Chinese astronomers in 1054 AD. They saw a bright flash in the sky, and there was a new star there. They called it a guest star, and today this is what we see as the remains of it. The new star appeared in 1054 AD. It was a star that had been there all the time, but it was just too dim to see until it went into a supernova explosion. And today, we see the remains of it. It's called the Crab Nebula. Now here's a close-up view of that same nebula. And what we've done here is we've taken optical wavelengths of light. So this is about the structure you would see through an optical telescope. And we've added to it what you see in a radio telescope, and what you see in infrared wavelengths, like the James Webb would see, and what you see in ultraviolet wavelengths, UV light, as well as X-ray wavelengths. So the farther we go to this direction, the more highly energetic the light is. So this is where we see the really interesting things. All of these pictures are combined together in this image here, and we can zoom in on it, and you can see it in greater detail. And so you can see right here in the center of the Crab Nebula, there's this spiral shape there. So there's a neutron star there that's actually spinning. So therefore, it's called a pulsar. A pulsar is a rapidly spinning neutron star that emits two concentrated beams of energy. So it's kind of like a lighthouse spinning out its energy in the universe and the region around it. Something sort of like this right here. So this is an illustration of pulsar B1933 plus 16. And this thing, every time its beam crosses the Earth, we can listen in with radio telescopes, just like we listen in on our phone, and we can hear a blip. And so I'm going to let you listen in on this star, and it might help if we have the fan turned off for just a minute while we go through this. If you don't mind just turning that off for just a minute here. I can only use the projectors here to transmit the sound. So there it is. This is the pulsar, and every time you hear a blip, it's actually sending a beam of energy across the Earth. And so it has made a rotation whenever we hear a blip. So it's spinning at 0.358 hertz. So that's the speed that the star is actually turning. Now we can go to another one, and we'll go to a faster one. This is the Vela pulsar, and you can see a picture of it there. This is the pulsar itself, and this is the region of space that caused that holds the supernova remnant. The gases have been cast out into that larger region. And here you can hear the Vela pulsar. This is spinning at 11 hertz. So it's this entire star spinning at 11 times per second. And so it's beating out an actual rhythm in the universe. So this is kind of like what we can think of as the music of the spheres. And it gets even better than this. When we go back to the Crab pulsar, we can hear this one spinning at 30 hertz. And there you hear it, this rapid fire rotation of this star, spinning these beams of energy out across the universe. And every time the beam crosses us, we hear a blip. And so we can hear. Now, if you're a musician, you understand how that the faster the frequency becomes, the more it transforms itself into a tone. And the higher the frequency, the higher the tone, or the higher the pitch. And so we can go to the next step, and we have PSR J0437, and it becomes a tone. It's almost a whine. It's spinning so fast, 174 hertz. And so now we have pulsars out there spinning so fast that we have tones being sent out across the universe as well. So some are beating out the rhythm, others are sending out the tones, and the recordings that we have are, of course, poor quality, so it doesn't sound very good right here. But then we have those that are completing out the symphony. They're finishing it off with a high-pitched 642 hertz sound that's being cast through the heavens by pulsar PSR 1937 plus 21. It's just amazing that these stars are spinning this fast. You would think they would completely fling themselves to pieces across their region of space. But what has happened is that these are the remnants of the supernova explosion. So the star's central core material has collapsed, imploded on itself into a very small, dense object where that 1 teaspoonful of it would weigh about 1 billion tons on the surface of the Earth. So that's hard to believe, hard to understand. I hope you have enough of a skeptical, enough skepticism that you kind of weigh that with a skeptical mindset, if I can get it out right. So, but that's what the claim is. So these stars are highly compacted and they're spinning at this high rate of speed. It's kind of like a skater that pulls its arms in. That's how these stars are. The stars are all rotating when they have their big, enormous size, but when they collapse in on themselves, then they spin much faster. Okay, we can have the fan on again. Thank you for turning that off for just a minute here. And what we have here is another example of how that we can see other things by looking at other wavelengths of light. This is the star Zeta Ophiuchi, and this is the same star with an infrared telescope. So when we look at the heat signature of this region of space, we can see how this star is plowing into an interstellar medium, and it's heating up this shock wave here. And so we can see what's going on in this star that we wouldn't see with just an optical telescope. Here's a galaxy. This is the optical view. This is the radio view. We can put the two together and we get this. So again, we can see what's going on here. Interesting things. Something significant is happening at the center of that galaxy. Stars that go through a life cycle where they start to transition from burning hydrogen fuel into other elements or going on to helium and then on to other elements. Eventually they come to iron, and when they get to iron, it's too hard for them to actually fuse iron and get enough energy out of it, so they start to collapse. A star the size of the sun will shrink down to a white dwarf, and a star the size of 1.4 to 3 solar masses would shrink down to a neutron star. And if there's enough solar material left over after a supernova explosion that it equals 3 or more solar masses, or 3 or more times the mass of our sun, it would shrink down to what's called a black hole. And so here, this thing is so dense that not even light can escape from it, so that's why it's called a black hole. So here we have an artist's depiction of a black hole. And these black holes are mysterious. They're kind of hard to understand, and they've been theoretical for a long time, but just recently we've had our first pictures, actual photographs of black holes. At first, astronomers theorized that they must be out there, and then they saw regions of space where there were stars that were moving around an area of seemingly nothingness at a high rate of speed. And I just want to see here if we can see that. Yes, there it is. So we'll go up to that, and I'll just show you what's happening at the center of our galaxy. There are stars that are orbiting around the X here at a high rate of speed, and astronomers didn't know exactly what it was that was causing this, but they knew that there had to be something there to anchor those stars to that orbit. The moon is orbiting around the Earth anchors it. The Earth is orbiting around the sun is the anchor point. But here, you see stars orbiting around this X, and there's no obvious anchor point there. What is it that they're orbiting around? It has to be something extremely massive, actually the mass of millions of suns, in order to support this high rate of speed of these stars whipping around it. So astronomers, of course, wanted to see what was there. And it turns out that it appears to be it's a black hole. Now, these black holes are simply, the easiest way to understand what they are is that they're just too much stuff in too small a space. We could actually turn the Earth into a black hole if we'd have a hydraulic press that would be strong enough to collapse it down. For example, we're on the Earth here, and we feel a gravitational attraction because there's lots of mass under us and it's pulling us downward. But gravity works according to the inverse square law, which means if you halve the distance between two objects, the gravity gets to be 4 times stronger. Halve it again, and it becomes 4 times stronger yet more. So that means that as we're standing on the Earth, feeling the pull of the Earth beneath us, we're actually feeling only the pull mainly of the crust right beneath us. And then as you go farther and farther away, the gravitational force decreases. So we're hardly feeling any kind of attraction at all of Australia and China far below us, 8,000 miles away. But if we could shrink the Earth and bring Australia and China and the Pacific Ocean up closer to us, then we could halve that distance and we'd be much heavier. And so eventually, as the Earth is shrinking, we would get heavier and heavier, and eventually I would take a seat with you because it would be too hard to stand. And eventually the buildings would collapse. Gravity would get so strong that we would all be eventually spread out as a thin veneer across the Earth's surface. All the mountains would collapse. Everything would become like a smooth marble. And by the time it would shrink down to about the size of 1 inch, the gravity would be so strong that the escape velocity of this planet would exceed the speed of light. So right now, the escape velocity of the Earth is over 20,000 miles per hour. But if the Earth were shrunk down to the size of a marble, it would be more than 186,000 miles per hour that we would have to travel in order to get off of this thing and float out into space. So that means that since light travels at 186,000 miles per second, it can't go fast enough to get off the black hole. So if we would shine our laser upward, the light might spill out of it and just bounce onto the surface of the black hole and be absorbed into it and never be seen again. So anything that comes to a black hole gets swallowed up if it comes too close. And if there's a star that's moving past the black hole, going out this direction, the star's gravitational attraction, the black hole's gravitational attraction latches onto it and does just like Jupiter did for the comet Shoemaker-Levy 9 that we looked at earlier. And it actually tugs on it and starts to pull it apart with its tidal forces in a process called spaghettification. And it pulls the star in these long, thin strands that wrap around and around the black hole as it spirals in through the accretion disk into the central region there. The central region has the event horizon, that's the boundary of the blackness, and that's the boundary of the black hole. That's the area where gravity is so strong that light can no longer escape from it. So everything there is on a one-way direction in toward the black hole. And at the very center of it, there's what's called the singularity, and nobody knows how big that is, but most physicists believe it's just extremely small, and that's where all the matter is piled up in the center. Now, it's hard to believe that we could actually compress matter down to this extent because we have objects that we think are solid and non-compressible, but even in solid matter like iron and lead, there's a tremendous amount of empty space between the molecules and lots of empty space between the atoms within the molecules and lots of empty space between the electrons and the neutrons within the actual atoms themselves. And then these subatomic particles also have empty space in them. So there's lots of things there that can be compressed. Now, as we move on here, we'll take a look at the first black hole image ever. Here is a picture of the galaxy M87, and we can see it. It's got a jet coming out of it. This is a picture through my telescope, the 10-inch telescope. It's an elliptical galaxy, so it's just a big glob of stars. It's just a featureless glow. But right here, there's a jet coming out of it, and the professional astronomers noticed that as well. And so they took a picture of it with the Hubble Space Telescope, and you can see the center of the galaxy there and this light years long jet with supersonic subatomic particles shooting out of the center of the galaxy. So they figured there must be something there that's causing this. And sure enough, they took a picture of it by linking together lots of radio telescopes across the Earth's surface to give an effective aperture for the telescope the size of the Earth, about 8,000 miles across. And so they got enough resolution to be able to see this tiny part of space, and they saw the accretion disk of the black hole and matter spiraling in to the event horizon that you see there. Greater than the greatness of all the mysteries of creation is the greatness of God above all the mysterious things He's created. These things leave us with lots of questions, but we know that God is great in being able to create these things and to sustain them as well. So we've talked about a lot of things this weekend, and it would just be great if the Creator Himself could come down and give a creation presentation just kind of like He did to Job, and how interesting and revealing that would be. Well, it turns out that God has given us that in the first book of the Bible, Genesis 1:16 here. He gives us a rundown of kind of like an overview of a lot of the things, most of the things that we've talked about this weekend. And he says it in Genesis 1:16, here it is, He made the stars also. This overwhelming universe summarized into this underwhelming statement. And so it's another window into the character of God. These things that are so great to us are almost like an afterthought to Him, by the way this verse reads here. Job 26 talks about ways that God is working in His universe. Verse 7 and 11 and 13 I've picked out here. They say, He stretcheth out the north over the empty place and hangeth the earth upon nothing. The pillars of heaven tremble and are astonished at His reproof. By His Spirit He hath garnished the heavens. And then verse 14 goes on to say, Lo, these are parts of His ways, but how little a portion is heard of Him, but the thunder of His power, who can understand? It's another way of saying we've only scratched the surface. So we've had details of how God works in His universe, but as God sits on His throne and His glory shines down on us and through us and to us, we're only seeing through a glass darkly and just barely scratching the surface and seeing a part of His true glory. For now we see through a glass darkly, but then face to face. Now I know in part, but then shall I know, even as also I am known. So this verse gives the connotation that when we get to the other side, we'll have an exponential increase in knowledge of God and the things that He's done and the way that He works and His attributes and His grace toward us. But it won't stop there because of what we read in Ephesians 2:7, where it says that in the ages to come, He might show the exceeding riches of His grace and His kindness toward us through Christ Jesus. So this tells us that throughout the eternal ages, He'll be revealing more and more things about Himself. And we will never come to the point where we run out of things to know about God. Because if we would, then at that point we would know all that God knows. And so we would in effect be omniscient as well, and we'll never get to that point. We'll never come to that same level, that same plane as God. So throughout the ages of eternity, we can continue learning more and more about this infinite God. Since He's infinite, there's an infinite amount of things that we can learn about Him. So it'll be an exciting adventure through all of eternity. There's lots of beauty here, and this beauty comes from a cursed creation. So can you just imagine what the new creation will look like? So what was Job's response when God was finished with his creation presentation? We can read that just a couple of chapters later after he had gone through those 64 verses. Then Job answered the Lord and said, "Behold, I am vile. What shall I answer thee? I will lay my hand upon my mouth." And I think this is a good example for all of us as we stand before a great and mighty God who has done so much for us and has done so much in the universe, even to make so that our lives can be supported. When we see His greatness, His all-sufficiency, then we should just be silent before Him and be willing to accept His way and His will at the expense of our own. Follow Job's example. So that concludes it for this evening. Thank you for your attention and your patience with me again. And we'll have a Q&A time here again. So if you have any questions, feel free to ask those questions. I think we have just a few minutes yet before we'll need to close for supper. Are there any questions? We could have the lights again, please.